Welcome back to The Deep Dive, the show where we take a massive stack of complex research and give you the blueprint for what you absolutely need to know.
It's good to be here.
Today, we are strapping in for a deep dive into an area undergoing what some very high-level consultancy research is calling a fundamental paradigm break.
That's a good way to put it.
We're talking about how cars are designed, how they're built, and maybe most importantly, how they evolve over their entire life cycle.
Yeah, this is a truly, a revolutionary strategic moment for the whole automotive industry.
It feels like it.
We've been poring over some really comprehensive research, a detailed consultancy-style analysis on the future of automotive R&D.
Okay.
And the core finding, the big takeaway, is this mandated, almost non-negotiable shift to what they call digital and intelligent R&D.
Or D&I R&D.
Right, D&I R&D.
Yeah.
And this isn't just a simple technical upgrade, it's a full-on strategic roadmap. It details the goals, the milestones for the next 2 decades.
2 decades.
And it all culminates in a 2040 vision where, frankly, the traditional car company as we know it might not even exist.
Okay, let's unpack that. That's a huge claim. We've heard the term digital transformation apply to everything, from coffee makers to city grids. But D&I R&D sounds like you're describing a complete structural and organizational rebuild for these car companies.
That's exactly what it is.
So what does this deep integration of digital and intelligent, big data, AI, large language models, IoT, the cloud, what does it actually mean for the car itself and for the process of creating it?
Well, what's fascinating here is just the scope. D&I R&D means these technologies have to be integrated across the entire product lifecycle.
The entire thing.
The entire thing. Think from the very first market analysis, the initial product definition, all the way through to manufacturing, service, and even how the product is retired.
Wow.
And this shift is really defined by 3 massive interconnected changes to the fundamental way you develop a product.
Okay, so hit me with those 3 shifts. What defines this new era?
First, you've got the absolute shift to a data-driven focus. This is where empirical real-world data becomes the core decision-making element.
So no more relying on gut feelings.
Exactly. You replace historical experience or, that gut feel with hard data. User behavior, performance metrics, regulatory insights. That's one.
Okay.
Second, the rise of the software-defined vehicle, the SDV.
We hear this term a lot.
And for good reason. It means software development takes center stage. The vehicle's functions are primarily controlled and defined by code. This is a crucial shift in focus, away from fixed hardware prowess to software agility and, importantly, upgradability.
And the third shift seems like it's the most commercially radical one.
It absolutely is.
Yeah.
The third is continuous iteration. The research often uses this term, SOP-x, or Startup Production X.
SOP-x.
It dictates that the R&D process doesn't stop when the car is delivered. The products have to continuously evolve post-launch through over-the-air updates, or OTA.
And that's the big change.
It fundamentally transforms the car from a rigid, fixed product into a dynamic, intelligent terminal that actually appreciates in functionality over its lifespan.
And that transformation, it points directly to the core conflict this roadmap has to solve, right?
Yeah.
Because traditional R&D, it relied so heavily on that rigid waterfall-like V-model development.
Right.
That system is notoriously slow. It focuses on a single, massive delivery, physical hardware integration. Once the car left the factory, that was basically it, the final product.
That's the tension, yes.
Yep.
The V model was great at what it did.
Yeah.
It emphasized robust hardware reliability, durability, things that are, non-negotiable for safety.
Of course.
But its fixed processes and these really long cycle times made it inflexible and just disastrously slow to respond to changing user demands, especially when you compare it to consumer electronics.
So the new D&I R&D model realizes you can't just abandon reliability.
You can't. So instead, it combines the structured reliability principles of the V model for the hardware foundation with agile development for all the software layers on top.
So you get the best of both worlds.
That's the goal. It enables that continuous delivery and quick response without sacrificing fundamental safety.
So we're fusing the necessary old engineering rigor with new software agility. The question is, how do you architect an entire company, an entire value chain to support that fusion? The sources clearly outline a structural framework for this. So what are the core pillars that hold this whole new system up?
That's the key structural piece. The entire future R&D system is strategically built around 4 mutually reinforcing interconnected pillars. And if one of them fails, the whole continuous evolution loop just breaks.
All right, let's dive into that architecture. We need to understand what each of these four foundational pillars does, and I guess how they all interact to support this idea of continuous product evolution.
So pillar one is data-driven product definition. You can think of this as the system's starting point and its brain.
The brain, okay.
This is the absolute shift away from relying on, tribal knowledge or subjective experience-driven decisions and moving toward empirical insight.
So what does that look like in practice?
This pillar relies on ingesting massive, multidimensional data streams. We're talking market trends, real-time user behavior, evolving tech roadmaps, regulatory changes, all of it.
All to achieve what?
Precise product definition and really rapid idea generation.
So DDPD is about cutting the guesswork out of that initial creative stage. Instead of a product planner, guessing what the market might want in 5 years.
Right.
AI and large models ingest all that raw data and convert those complex, messy concepts directly into structured, actionable engineering language.
Exactly. That has to dramatically accelerate the product planning phase.
Right.
It defines the what and the why with data.
Got it. What's pillar two?
Pillar two is the software-defined vehicle, or SDV. This acts as the system's nerve center.
Okay, so if data is the brain, software is the nervous
A
system.
perfect analogy. This is the mechanism that actually executes on that data-driven definition. It signifies the transition where the core value and the business model shifts away from fixed hardware and towards software control.
And SDV is what allows for that rapid iteration and personalization, right?
It's essential for it. And the research notes this is already advancing really fast toward what they're calling the AI-defined vehicle, or AIV concept.
So AI becomes the system architect itself?
Eventually, yes.
That makes perfect sense. The software is what determines the car's personality and capability, and it's the only part you can really update in real time. But the process of designing mechanical, electrical, and software parts at the same time, that used to be a nightmare of incompatible systems.
Total nightmare.
So how do you break down those massive engineering silos?
And that is pillar three, product collaborative design and development.
Okay.
This is the system for breaking down walls. And not just between departments, but across the entire enterprise and the whole supply chain.
How? What's the tool for that?
It mandates heavy digitalization and platforms. The digital twin is central here, alongside something called model-based systems engineering, or MBSE. The goal is seamless cross-domain collaboration, or what we can call mechanical electrical software coordination. Without that integration, the speed promised by SDV is just impossible.
MBSE is key here, I'm guessing. It essentially means creating a single authoritative digital model that all the different disciplines work from.
Yes.
Instead of relying on, fragmented documents and separate CAD systems, that must dramatically reduce physical prototypes and design errors.
Absolutely. If a requirement changes, MBSE ensures every single subsystem automatically registers the impact. No more surprises late in the game.
Okay, so that brings us to the fourth and final pillar.
Right. Pillar four, full lifecycle development management. This is the system for continuous self-evolution.
A feedback loop.
It is the feedback loop
Sure.
that ensures R&D doesn't just stop at delivery. It runs through the product's entire life, maximizing the car's utility. And the critical mechanism here is the demand data algorithm closed loop.
Demand data algorithm.
It takes that real-time user data and feeds it straight back into the R&D process, which enables that SOP-x automatic iteration mechanism and constant targeted OTA updates.
Okay, so here's where the business insight really crystallizes for me. If you look at these four pillars, data input, software core, collaborative delivery, and continuous feedback, they basically form a perpetual motion machine for generating value.
That is the ultimate strategic conclusion of the consultancy analysis. The car moves from being a depreciating hardware asset, something that loses a huge chunk of its value the second you drive it off the lot,
Right.
to a continually appreciating service asset. Because the product evolves alongside the user, continuously adding new features, improving performance, it maximizes that customer lifetime value, or CLV.
And this transformation of R&D is the only way for traditional automakers to survive that shift to becoming a mobility service provider.
It's the only way.
Now that we have the framework, let's establish a baseline. How far along are we globally in actually implementing these four pillars? And what are the major strategic differences we're seeing between different regions?
We see broad global recognition that data-driven definition is essential. Everyone agrees on that.
Right.
But the application of that definition differs really significantly. McKinsey and J.D. Power reports highlight some interesting contrasts.
Like what?
In the U.S. and European markets, The focus is heavily on ADS advanced driver assistance systems and fundamental vehicle safety functions.
Why there?
It's largely driven by strict, established regulatory standards and the resulting consumer demand for certified safety. It's a mature market priority.
So data is being used to optimize reliability and safety features first. How does that contrast with what we're seeing in the Asian market, particularly in the regions this roadmap is targeting?
The contrast is really clear. J.D. Power reports indicate that for consumers in Asian markets, vehicles that offer advanced, intelligent, and personalized experiences score significantly higher in satisfaction rankings.
So cockpit features, navigation, personalized services, that kind of thing.
Exactly. That focus on immediate experiential intelligence is also mirrored in regulatory strategy. The EU, for example, prioritizes privacy with very strict regulations like GDPR.
Right, governing data security and cross-border flow.
Whereas in the markets driving this D&I roadmap, there's an aggressive push through government action plans, explicitly supporting data resource development and collaborative models across the entire supply chain to speed up innovation.
That difference in data strategy strict protection versus aggressive ecosystem-wide collaboration, that sounds like a huge competitive factor. It really shapes the pace of this transformation.
A massive factor.
Let's move to collaborative design. Are the international legacy automakers still ahead in terms of pure operational maturity?
In foundational operational platforms, yes, they have significant maturity. International players have spent decades building these robust, global distributed collaboration systems.
Can you give an example?
Sure. Volkswagen's use of large-scale systems like Siemens Teamcenter shows what's possible. They've established these three-layer architectures that achieve huge efficiency gains. We're talking over 80% improvement.
And the data sync?
Critically, they can compress the data synchronization cycle across global teams to just 24 hours.
24-hour data sync is essential when you have design teams in different time zones. That is lightning fast compared to the weeks it used to take to consolidate physical or fragmented digital documents.
Right. Now, domestically, the source points out some persistent challenges. There's platform fragmentation and a tendency toward what they call purchase-style collaboration with suppliers.
Meaning it's more transactional.
Very transactional, and it lacks deep co-development. This leads to significantly lower rates of early supplier involvement, which is a key metric for gauging collaborative depth.
How much lower?
International leaders have supplier involvement exceeding 80% right from the project initiation phase. They integrate their expertise from day one. That's a huge gap.
So whether we look at data strategy or collaboration, the common thread here is software. The global trend really zeroes in on the accelerating role of software, moving from just a utility to defining the very value of the car.
Absolutely. Software is becoming the core driver of vehicle value, and this is where AI and large models become critical tools for the R&D process itself.
Oh, so?
They accelerate R&D knowledge capture. They allow for far more sophisticated idea generation by synthesizing vast data. And most importantly, they enable autonomous real-time OTA updates, driving that personalization.
So we're moving toward a system where AI is doing more of the groundwork.
A lot more. A system where AI algorithms automatically generate test cases with over 95% coverage, replacing so much of that tedious manual human testing effort.
That leads perfectly into how we measure this progress. If we're talking about moving from V-model rigidity to AI-driven autonomy, there must be a way to grade maturity. Tell us about the IMR scale used in this research.
Right, the research uses the Intelligent Manufacturing Maturity for R&D scale, or IMR. It runs from IMR 1 to IMR 4. It serves as the yardstick to measure the evolution from basic digital capability all the way to that 2040 goal of full self-evolution.
Okay, let's define these levels clearly. What do they represent in terms of actual R&D capability?
IMR 1 is the basic or initial level. This is essentially the traditional V-model development, just starting to incorporate agile methodologies on the periphery. You have some basic digital tools, some limited internal data sharing, but the core processes are still pretty fragmented.
So the first toe dip into digitalization.
It's just about establishing the foundational digital assets and IT infrastructure you need to move forward.
And IMR 2.
IMR 2 is the collaborative or digitalized level. This represents a significant successful step. You've achieved substantial digitization coverage. We're talking around 80% coverage in product definition scenes.
Okay, so you're mostly digital by this point.
You introduce data-driven decision-making, you move towards central compute architectures, and you establish comprehensive digital coverage across 80% of R&D scenes. The systems are connected and digitalized, but not yet intelligent.
So IMR2 is about connecting the dots internally and making data the standard across the enterprise. What happens when we hit true intelligence and integration?
That's IMR3, the intelligent or integrated level. Here, you see deep AI application. The distinction is that AI is no longer a bolt-on tool. It's integrated into the core architecture.
What the sources call AI for OS.
Exactly. AI is integrated into the core OS kernel, often called AI union definition. At this stage, 90% of the hardware must be reconfigurable by software, and collaboration routinely crosses enterprise boundaries.
And the car starts to feel truly intelligent.
Right, because complex functions like predictive maintenance become routine.
And the ultimate goal, the apex that the 2040 roadmap is designed to hit.
IMR4 is the autonomous or self-evolving level.
Yeah.
This is the 2040 vision. The system becomes AI native. AI functions as the OS kernel itself. We call it AISOS, or the AI-defined vehicle, AIDV.
And what can it do?
AI defines 100% of the hardware function in real time. We see global crowdsourcing, a full lifecycle data self-circulation. The car is continuously and autonomously refining itself with minimal human intervention.
That is a staggering jump in capability. It requires massive organizational change. It shifts the entire purpose of the engineering team from designing a static product to managing a continuously evolving intelligence.
It changes everything.
Okay, now let's look at the specific 2040 vision and the staged milestones for achieving that IMR4 apex.
So the ultimate strategic vision, and this is confirmed by this consultancy analysis, is not simply to build a faster or safer car. It's to transform the automobile into a self-evolving life form.
A self-evolving life form, that's a powerful phrase.
It is. This intelligent organism is meant to be deeply integrated into a massive, interconnected infrastructure, the human vehicle road energy network cloud ecosystem.
Yeah.
So the R&D process has to evolve dynamically to support that continuous systemic evolution.
That analogy powerfully captures the concept of a product that improves the longer you own it. So how do we break this 2-decade journey into measurable, achievable stages? What are the 3 strategic milestones?
The first phase is phase 1, Digital Collaboration Foundation, and that's targeting the milestone of 2030.
Okay, 2030. What's the core goal?
The core goal here is establishing the processes for flow-driven digital collaboration. This means setting up that SOP-x closed-loop iteration we talked about, achieving significant internal digitization coverage, around 70 to 80%, and implementing the first generation of the software-defined vehicle concept.
With a central compute architecture.
Yes, and standardized software interfaces. This is all about getting the digital foundation laid properly.
Setting the foundation for digital connectivity and software control. That prepares us for the middle stage, which is phase 2, intelligent integration era, reaching 2035.
Correct. The core goal here shifts from just digitization to data-driven cross-domain integration. This is where AI moves from being an auxiliary tool to a core decision maker.
So what's the big target for 2035?
We aim for AI union definition, or AI for OS, which allows for that deep reconfigurability. This stage enables 1,000 cars, 1,000 software personalization.
Moving beyond simple feature options to what?
To individualize service stacks for every single vehicle. And critically, cross-enterprise collaboration becomes the routine standard, not the exception. This phase correlates strongly with achieving IMR3 maturity.
Integration is the operative word there. Integrating AI, integrating data, integrating the supply chain. Finally, the strategic pinnacle, phase 3, AI-native self-evolution apex by 2040.
This is the realization of the ultimate vision, correlating with IMR4 maturity. The core goal is AI-native and ecosystem co-creation.
Which means achieving the AI-defined vehicle.
ADV, or AI as OS, where 100% of hardware functionality is defined and managed by AI in real time. Quantifiably, the R&D cycle has to be slashed by 50%.
And the business model?
It flips completely. Software becomes the undisputed primary revenue source, exceeding 80% of total company revenue.
That is the most staggering business impact metric of the entire plan, shifting software revenue from a niche component to the vast majority of the company's income. It fundamentally redefines the company's organizational structure and core competencies.
Precisely. The research explicitly states that the successful shift from SDV to ADV transforms the traditional automaker from a simple vehicle manufacturer into an intrality or mobility service provider by 2040.
So they're selling continuous service bundles.
Leveraging AI and data as the core asset, their primary competition is no longer other car companies, but tech and service companies.
Okay, that gives us the big picture and the major deadlines. Now we can transition into the technical detail. For the next 4 sections, we need to dive deep into the specific roadmaps for each of those 4 pillars. Let's detail the measurable targets, the required technology shifts, and the organizational and ecosystem changes planned for 2030, 2035, and that 2040 final apex. Right, pillar one, the brain of the operation, data-driven product definition. The goal here is moving from relying on the expertise of a few product planners to achieving autonomous product definition powered by AI.
And achieving unprecedented accuracy and speed in capturing what the user actually needs.
Let's start with the 2030 goals. The focus is on data-assisted decisions. What are the targets?
They're about establishing a measurable foundation. First, data collection coverage needs to exceed 80%. This means we're systematically capturing user feedback, market trends, and technical debt on a global scale.
Okay, and the process itself.
Digital coverage of the product definition process has to reach over 70%.
80% data collection is a huge undertaking. What kind of technological infrastructure do you need to hit that 2030 target without just drowning in unmanageable raw data?
Well, it relies on utilizing AI, big data, IoT, cloud computing, but also a crucial indexing technology known as RAG.
Or RAG, Retrieval Augmented Generation.
Yes, we often hear about large models, but RAG is the critical technology here. It builds a systemized, visualized knowledge platform that can ingest all those raw sources, market reports, user forums, regulatory policies.
And it grounds the AI.
It grounds the AI's idea generation in verified facts. It prevents the AI from hallucinating product definitions and ensures those multidimensional insights are translated accurately into technical requirements.
That grounding mechanism sounds vital for engineering. What about the process changes required by 2030?
The R&D process has to establish robust cross-departmental collaboration early on, paired with intelligent over-the-air update management processes.
And the ecosystem.
The ecosystem has to begin building enterprise-level open creative application systems, promoting resource integration across the immediate supply chain. The aim is a reliable, digital conversion of user needs into engineering language.
Which reduces cycle time and minimizes those expensive late-stage mistakes. Okay, moving to 2035. The goal is data-dominated definition. The metrics jump, demanding higher quality input and output.
They do. Data collection coverage has to exceed 90%, and critically, the definition accuracy, which is a measure of how closely the final product meets the market need identified by the data, that has to reach over 80%.
Wow, so the technology has to mature significantly. It's moving past simple data ingestion.
By 2035, AI needs to enable what's called scenario intelligent orchestration.
What does that mean?
It means the system can automatically sequence and organize features and technical requirements based on predicted user context, like recognizing a commuter scenario versus a weekend road trip scenario, and then partially automating the product planning.
And edge computing becomes critical.
Absolutely vital. It boosts the real-time data processing at the vehicle level to close those feedback loops faster than ever.
So the system isn't just digesting data anymore, it's actively helping plan the product architecture. How does the ecosystem mature to support this data-dominated environment by 2035?
Cross-enterprise collaboration needs to be routine and mature. It needs to be supported by industry-level standards for creative conversion, taking a high-level concept and turning it into a tangible realization plan consistently.
And data sharing.
The industry has to establish mechanisms for internal data sharing for win-win coexistence, overcoming that traditional competitive data hoarding. The research emphasizes that by 2035, 80% of key product definition decisions must be demonstrably influenced by data, not managerial instinct.
Finally, the 2040 apex. Model autonomous definition. This is the realization of true, unsupervised AI R&D operating at IMR4 levels.
By 2040, we're seeing definition accuracy hitting 95% or higher, almost eliminating poor product choices. The technologies here are radical and forward-looking.
Like what?
Full application of quantum computing, which offers that exponentially enhanced processing power you need for hyper-complex digital twin simulations.
You also see blockchain?
Right, for data provenance, security, and traceability across the globe. And multi-agent systems, essentially specialized intelligent bodies, which allow multiple AIs to work collaboratively on different parts of the product definition at the same time.
So VR and 3D printing are just for confirmation?
They're reduced to rapid physical prototyping, used only for final aesthetic confirmation.
The process becomes almost entirely AI-driven.
Yes. The business process closed loop is AI-driven, and global vehicles autonomously update themselves based on local regulations and immediate user needs.
And the ecosystem goal?
It's massive, achieving globalized cross-industry data connection and automated trading of digital assets. We're forming a complex, global, closed-loop creative ecosystem that extends far beyond automotive into energy, smart city, and cloud infrastructure.
Yeah.
Pillar 2, the nerve center. The transformation here is radical. Software has to evolve from just controlling the hardware to autonomously defining and evolving the entire car's functionality.
And this is the path to maximizing service revenue. That's the ultimate business goal of the whole roadmap.
That's it.
Let's start with 2030, the establishment of the SOA architecture and automation. The business stakes are high right out of the gate. What are the revenue targets for this foundation phase?
By 2030, the quantifiable target is that software and service revenue must reach 35% of the total company revenue.
35%. That requires a seismic shift in how the company earns money.
It's huge. And technically, the car needs to adopt the service-oriented architecture, or SOA, running on a central compute platform integrated with zonal controllers.
And this physical and architectural change is what enables that crucial soft-hard decoupling and interface standardization.
Right, you separate the code from the physical location of the wiring.
The SOA architecture is what allows functions to be added or moved without major physical rewiring. And development speed needs to jump, what, 10x?
It has to jump dramatically to support the continuous iteration model. DevOps pipelines need to enable continuous integration and delivery, CI/CD, allowing for daily software builds.
A 10x speed increase.
At least. And AI starts participating in the R&D division of labor, taking over routine coding tasks. Unified virtual simulation reduces the reliance on costly, slow physical hardware prototypes,
And you need to standardize interfaces.
so that traditional and software supply chains can co-develop components.
Okay, moving to 2035, we enter the era of AI union definition, or AI for OS. This sounds like a much deeper functional integration than the initial SOA foundation. What's the financial target here?
The financial stake is massive. Software and service revenue has to reach 60%. This firmly establishes software as the major profit source.
And technically.
Technically, 90% of hardware functions must be reconfigurable by software. The AI for OS part means AI is integrated directly into the core OS kernel rather than running as just an application on top. It's making system-level decisions.
That's a deep integration. What platforms support this high level of intelligence, and how does testing keep up with the speed?
We shift to a model-based definition, MBD, plus an AI dual-engine platform. This combination allows for AI algorithms to autonomously generate test cases, aiming for a stunning 95% test coverage in the virtual environment.
And process-wise?
A multi-agent collaboration framework starts handling the complexity of organizational innovation. And the vehicle architecture gains critical capabilities, self-healing and performance tuning, all automated based on real-time runtime data fed back through Pillar 4.
And the ecosystem must be completely open by then to feed the demand for personalized software?
Yes, a complete third-party developer ecosystem has to be established, covering critical areas like chassis controls, smart driving, and cockpit features. This is how you achieve 1,000 cars, 1,000 software individualized, dynamically updating software stacks for almost every vehicle on the road.
Finally, 2040. The AI native definition, AIDV, or AI as OS. This is the IMR4 apex, the ultimate revenue target.
Software and service revenue must exceed 80%. At this point, the automobile company is undeniably and functionally a mobility service provider.
And technically, 100% of the hardware functions are defined by AI in real time.
Yes, and this is where the multi-agent collaboration framework replaces the SOA layers entirely. The AI is the operating system, orchestrating every vehicle function dynamically.
That transition from structured SOA layers to an entirely AI-native framework is the key architectural shift of the decade. What about the development chain itself?
AI takes over the entire development chain, from analyzing raw user feedback to code generation, optimization, testing, and deployment.
And this forms a centralized hub.
A hub of embodied intelligent software evolution. The ecosystem shifts to an open ecological alliance, driving personalized development environments. And critically, a software digital asset trading platform is established for cross-enterprise module circulation,
Which fuels a cross-industry open source community.
spanning automotive, energy, and smart city sectors.
All right, Pillar 3. This is all about removing organizational and technical friction to maximize efficiency and speed through collaboration. The goal is that seamless mechanical electrical software coordination we identified earlier, eliminating the silos.
That's right.
So let's start with 2030, aiming for enterprise-level collaboration. This is about massive internal efficiency gains.
It is, and quantifiably, the R&D cycle has to be shortened by over 20% compared to traditional benchmarks. Physical prototypes must be reduced by 50%, with verification shifting to virtual models.
And digital coverage.
Digital coverage of R&D scenes has to exceed 80%.
A 20% reduction in R&D cycle time is huge. What technology makes internal collaboration flow that smoothly?
AI large models are used to drive dynamic task decomposition, breaking down complex design goals and assigning them priorities based on dependencies. And the initial widespread application of model-based systems engineering, MBSE, is essential.
Along with establishing true mechanical electrical software coordination.
Yes, and we need robust data interoperability platforms, seamlessly linking the bill of materials, the BMOM, with CAD, CAE, and CAM data. This ensures everyone is working from the same live source.
And the process is required to support this. You can't just rely on technology. The culture has to change.
Absolutely. The automated design review rate needs to hit 90%, streamlining decisions that used to bog down management. We have to see the widespread application of parallel design processes, system, component, and module development, all happening concurrently, not sequentially.
And the ecosystem.
It needs early, formal engagement from academic institutions and strategic suppliers, integrating them into the MBSE model from the very start.
Okay, moving to 2035. Industry-level collaboration. This means the walls come down between the main manufacturer and the strategic suppliers, forcing standardization.
It does. R&D cycle shortening hits over 30%, and full lifecycle collaboration efficiency increases by 70%.
The technology deepens here.
With the full utilization of quantum computing, specifically to run exponentially complex, concentrated simulations across multiple participants. We use the digital twin for manufacturing processes and the product twin for remote, multi-party design and review.
And unified communication protocols become the norm.
Standardized data interfaces, making that cross-enterprise data flow seamless and secure.
The product twin concept seems fascinating. A perfect digital replica of the vehicle running alongside the physical one? What about integrating the entire value chain process?
The full integration of R&D, production, supply, sales, and service must be achieved via agile processes and AI.
AI is used to actively bridge data gaps between these typically siloed stages.
And the ecosystem has to unify standards.
Unify industry data standards, establish joint innovation labs, and create secure cloud collaboration networks with suppliers and research institutes to share IP without sacrificing security.
Finally, 2040. Global crowdsourcing and AI automation. This is the ultimate reduction in physical labor and the ultimate expansion of the knowledge base. The R&D cycle has to be shortened by more than 50% relative to the traditional V model. And critically, physical prototypes are used only for final confirmation, with verification cycles drastically shortened.
Crowdsourcing efficiency increases by 90%.
It does. The technology relies on the full application of the multi-agent collaboration framework, user co-creation cloud platforms, and the development of autonomous AI design assistants.
And these assistants are capable of completing what?
Over 30% of routine design tasks.
An AI colleague handling almost a third of an engineer's workload. That's a massive shift in organizational demand. How autonomous is the process management at this stage?
The R&D process digitization rate exceeds 95%. The core is the deployment of a multi-agent framework for cross-scenario dynamic task scheduling, creating an autonomous decision-making system.
And the ecosystem achieves full maturity.
The global crowdsourcing and co-creation R&D model, utilizing the digital twin across the entire value chain, including soft ecosystem co-development with global partners and individual users. Right. Pillar 4. This is the crucial closed-loop mechanism that ensures the whole system works. The goal is making sure the product is ever new and improves with use. That continuous evolution cycle powered by data.
Let's start with 2030. Data closed loop and agile iteration. What are the metrics for this continuous evolution model in the initial phase?
OTA coverage has to reach 70% of the fleet. Software iteration cycles need to be shortened to within a quarter, so quarterly updates become standard. And hardware iteration must be supported within 1 year.
What's the central mechanism?
Establishing the demand data algorithm, SOP-x automatic iteration mechanism in a deep, continuous closed loop. This ensures every piece of data generates an algorithmic response that leads to a new feature or an improvement.
So user feedback immediately generates data, which the algorithms use to propose and implement updates. What technologies close that loop reliably?
We see the integration of FOTA firmware, OTA V2X, communication, AI, and big data analysis. Crucially, we introduce intelligent body technology for autonomous optimization in mature R&D scenarios.
Meaning the car can fix or tune itself in routine situations.
Yes. And this initial phase enables the 1,000 people, 1,000 cars scaled customization model.
Okay, moving to 2035. Predictive maintenance and intelligent diagnostics. We move from simple customized iteration to proactively managing the vehicle's health and performance.
Quantifiably, OTA coverage reaches 90% of the fleet. Software iteration cycles shorten dramatically to monthly updates, and hardware iteration is supported within 6 months.
And the soft-hard decoupling enables seamless optimization.
Meaning updates happen in the background without user interruption or notice, minimizing downtime. This realizes the 1,000 cars, 1,000 software, true personalized service goal.
Seamless optimization is a key consumer experience marker. It means the system is so integrated, the user only experiences the benefit, not the complexity of the update.
Exactly. Technology includes seamless OTA implementation, dynamic tagging to classify data quickly, and blockchain for data security and traceability across the vehicle's life.
Which also supports machine learning-based remote diagnostics.
Yes, often based on e-architecture and software test big data. The process focuses on the full integration of the R&D production supply sales service value chain, with data closure becoming real-time via edge computing and cloud platforms.
Finally, 2040. Autonomous optimization and ecosystem coexistence, the end state for lifecycle management corresponding to the AIDV.
OTA coverage reaches 100% with ultra-agile response, meaning software updates are happening weekly, and the hardware platform supports bi-monthly iteration schedules.
And the mechanism realizes the open crowdsourcing product operating model.
Pulling in external innovation dynamically.
Weekly software updates and hardware supporting bi-monthly changes. That requires unimaginable architectural agility. What specific technologies sustain that hyper-evolution?
High-order large models and digital twins create vehicle mirror simulations, a perfect virtual replica for real-time testing and preemptive updates.
And the vehicle systems are deeply interconnected.
With traffic and energy networks, enabling data-driven city-level scheduling and optimization. The process achieves full life-cycle data self-circulation, from R&D all the way to recycling.
And AI autonomously mines data value.
Achieving a real-time user feedback closed loop, driven by a composite intelligent body covering the entire enterprise.
The overarching goal is the formation of that massive human vehicle road energy network cloud ecosystem. R&D extends its depth and breadth, moving from developing isolated products to delivering continuous, perceptible value across the entire lifetime of the intelligent node.
It's the final stage of the mobility service provider transition, where the car is constantly serving multiple masters: the driver, the energy grid, and the urban traffic network, optimizing its own code and function based on the collective data output.
Wow. We started this deep dive talking about a fundamental paradigm break, and looking at that 2040 vision, the AI-defined vehicle, autonomous design assistance, 80% software revenue, that feels like an understatement.
It really is.
We've mapped the transformation from the rigidity of the traditional V model to a vision of a self-evolving life form. The shifts are staggering and quantifiable, R&D cycles slashed by 50%, physical prototypes virtually eliminated, and the entire business model flipped on its head.
And the key strategic conclusion from the consultancy analysis is the absolute interdependence of these four pillars.
Yeah.
They're not isolated. They form a tightly integrated, dynamic evolutionary system.
Right.
Data feeds the definition process, that's pillar 1. Software enables the function, pillar 2. Collaboration ensures rapid, efficient delivery, pillar 3. And lifecycle management closes the loop with continuous feedback, pillar 4, which generates the new data needed for the next round of self-evolution.
It's a self-feeding, self-improving system where every piece of user interaction generates the data needed for the next round of autonomous design improvement. And this need for continuous improvement is what forces all the technology shifts we discussed, the need for RAG, for MBSE, for AI, for OS.
Exactly. This total transformation of the R&D process is precisely what makes personalized, self-improving mobility possible.
So why does this matter to you, the listener?
It matters because the automobile is no longer just a depreciating product. It's becoming a fully integrated, intelligent node in the larger ecosystem. Its ability to optimize traffic, manage energy consumption, and customize itself makes it an essential part of future city and cloud architecture.
And considering the pace of automation, with AI taking over 30% of routine design tasks by 2040, and the AI itself becoming the operating system, what happens to the people who build and manage these systems?
That raises a really important question, something for you to explore on your own as you digest this monumental roadmap. If the goal is to stop creating fixed products and start nurturing life forms that continuously self-optimize, What new organizational structures and skill sets will be needed? If the product is never truly finished, what is the role of the human engineer in a world of AI-native R&D, and how do their tools, their incentives, and their career paths change?
A question that redefines an entire profession in the face of autonomous intelligence. Fantastic deep dive. Thank you for guiding us through this incredibly dense and strategic material.
My pleasure. It was great.
And thank you for joining us. We'll see you next time on The Deep Dive.